Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Also welcome to the NEET crash course series. Student, in this class I will teach you the motion in straight line. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with a good rank. Now let's start about the class. So motion in a straight line, three parts mainly. One part is numericals with equation of motion. Okay, and second part graphs, and third part instantaneous velocity and acceleration. So mainly three parts. So first I discuss some numericals with the help of equation of motion. Mainly three equation we know. First equation is V equal to U plus AT. Second, S equal to UT plus half AT square. And third is V square equal to U square plus 2AS. So this equation mainly uses when a body moves with constant acceleration. For motion with constant acceleration, that is when a body moves with constant acceleration, then we can use only three equations. And also there is another equation which is the distance travel in nth second equal to U plus A by 2 2n minus 1. Nth or tth second. N is time. N is total time travel. This means, what is this? This means distance travel in last 1 second. If a body travels for n second, suppose the time taken is here n seconds, this is n seconds. Now n minus 1 second up to this last 1 second is called this nth second. Last 1 second is called nth second. So distance travel in last 1 second is Sn. This is the formula of this. This is distance travel in last 1 second. Velocity, a path, two-third part with velocity v1 and 1/3 part moves with velocity v2, or this 1/3 part moves with velocity v2. Now what is the average velocity? Average velocity equal to what? So if a body moves with 2/3 part of the whole journey with speed v1 and 1/3 part of the whole journey with speed v2, then what is the average speed? What is the average speed of the body? Now we know speed equal to distance travel by total time. Distance travel equal to, here suppose this part distance is total, if we take the total distance is x, then this part is 2/3 of x, and this part is, so we have to total, if we take the total path is x, then we have to consider, we just calculate the time taken t1 and t2, this time and this time we calculate the time. So distance travel equal to x and time taken t1 plus t2. Now what is the time taken? t1 equal to we know distance by velocity v1, and time taken t2 equal to x by 3 velocity. In a motion of a straight line, velocity and speed will be same. So speed or velocity, I can use the word speed or velocity. So t1 plus t2, that is 2x by 3 plus 2x by 3 v1, and this equal to x by 3 v2. So the answer is x cancel, x divided by x common, 2 by 3 v1 plus 1 by 3 v2. That is this is the answer. So 2 plus v1, 2v2 plus v1 into v1 v2. This is the answer. This is the answer. So passes a light post with velocity u1 or u. Next problem is that a train passes a pole with a speed v with a speed u. Now, and it passes the end of the train, that is end part of the train passes the light post, same light post with speed v. Now, what is the velocity? What is the velocity of the mid part? When the mid part of the train passes through the same light post, what is its velocity? This is the question. Now, this velocity, this is mid part. This velocity what? So this is the question. You have to answer this question v dash in terms of u and v, same train. That is like, I repeat the question once again. If a train passes through a light post with speed u and he crosses or passes the end part, and the end part of the train crosses or passes the light post with speed v, then what is the mid part of the train passes with what velocity? Now, with what velocity mid part of the train passes? So this is the question. Now, to solve this question, we know the acceleration of train here constant. Acceleration of train, in the question given that acceleration of train is constant. Acceleration train be a. So, and the length of the train is L. So here we can write the equation. Suppose a bullet crosses a planks, and after crossing the planks, the bullet loses its speed by 1/20th part. That is, if the bullet enters with velocity v u, then the velocity after crosses the one plank becomes u minus u by 20. So, if the bullet, question is, if the bullet losses by 1/20th part of its initial velocity, then numbers of planks required to stop the bullet what? So this is the problem. Now, given that the bullet losses by 1/20th part of its initial velocity, then the number of planks required to stop the bullet what? So suppose, what is the number of bullets? What is the number of planks required? Now, let the thickness of the plank be x and n numbers of plank required to stop the plane. So what is the thickness? Thickness will be nx. Okay. Now, speed, entering speed u and final speed now 0. So first we have to write from this one equation. The equation here will be final velocity here v equal to u minus u by 20. Okay, that is 19 u by 20. So we write the equation x v equal to this. So put here. So 2ax we get 19 square by 20 square. So we get this, that is u square into 400 minus 90, 400, 361, that is u square into 39 by 400. So this is this. Now here the equation will be what? Here the equation will be final velocity 0 for this. The final velocity 0, initial velocity u, to distance travel equal to nx, and retardation becomes same. For this plank and also this plank. Average retardation we take the same. So here n equal to, from this, n equal to u square by 2ax. Now put here 2x, value of 2x equal to this. So what the result? U square by 2x equal to this. So this is greater than 10. So we have to take the number of planks is 11. This is the answer. Velocity and acceleration. So what is the instant velocity and acceleration? Formula is dx by dt, and acceleration equal to dv by dt, and this also v into dv by dx. We know that velocity equal to this and acceleration equal to this. So this is instantaneous velocity and instantaneous acceleration. So what is the instantaneous velocity and what is the instantaneous acceleration? The one video have been discussed elaborately with instantaneous velocity. student can watch the instantaneous velocity and acceleration. So some problem I will discuss. Suppose distance travel equal to given this. Suppose distance varies with time is this. Find acceleration when velocity is maximum. When velocity is maximum. Find acceleration when find distance travel. Find distance travel when velocity is maximum. Velocity is maximum. This is the question. Find distance travel when velocity is maximum. So what? So this is the question. Now we know velocity solution is this. Velocity equal to dx by dt. Dx by dt equal, that is 60 square minus 80 plus 5. So velocity equal to this. Now acceleration equal to dv by dt. dv by dt, that is 60 minus 8. Okay. Now the velocity is maximum. What is the theory? Velocity is maximum. This is the acceleration. Now we know if y is the function of x, then y is maximum when dy by dx equal to 0. This is the theory. Y is maximum when dy by dx is 0. So here velocity is the function of time. So velocity is maximum when dv by dt equal to 0. Velocity is maximum when dv by dt equal to 0. That is, this becomes 0. That is t equal to 8 by 6. That is 4 by 3. So at this time velocity is maximum. So at this time, what is the distance travel? Distance travel, put here 4 by 3. We get x equal to this. So x equal to 4 by 3 whole cube minus 4. So you calculate this. This is the answer. Sometimes t equal to root over x plus 3. Find velocity and find velocity position. Suppose here x is position and acceleration of particle at t equal to 2 seconds. T equal to 2 seconds. So t equal to 2 seconds, we get position by putting t equal to 2 seconds here. Root over x equal to, suppose velocity, position and acceleration of particle at t equal to 4 seconds. So t equal to 4 we put here, x equal to 1 meter. This is the position. Now what is the velocity and acceleration? So we have to root over x equal to t minus 3 squaring. This is x. Now we can easily differentiate this. So velocity equal to this and acceleration equal to dv by dt. The acceleration is constant. The answer is this, and acceleration is this, and velocity equal to 2 into t. This is the answer. Sometimes velocity is the function of x. Suppose v equal to find velocity and acceleration at x equal to 4 meter. So what is the answer? Find velocity and acceleration at x equal to 4 meter. we get velocity equal to, put x equal to 4 here. This is velocity, but what is the acceleration? Now here we have to use acceleration equal to formula v dv by dx. We have to use this. Now we can easily find dv by dx. So dv by dx equal to 3 into root over x, derivative of root over x equal to 1 by 2 root x. So 0. This is now a equal to v into dv by dx. So if we put x equal to 4 here, so this is the answer. So this is the answer, acceleration. So this type of question now how to solve the motion of the train with constant acceleration, motion of train with now the problem of motion of train with constant acceleration and retardation. A train starts from station A with constant acceleration, and before reaching at the another station, suppose B, before reaching at another station, the train apply the brakes, apply the brakes, so retardation is produced. Now the retardation is suppose B. So what is the maximum velocity gain? Question is here, maximum velocity of train and distance travel by train if total time taken bt, the problem will be solved by graphical method. So if we draw the graph, velocity time graph, so what the graph will be this. Now the slope of this line, this is velocity time graph. The slope here, the slope of VT graph is acceleration. We know the slope of the VT graph is acceleration, so the slope of this line is A and the slope of the line is B. Now here the velocity is maximum, so Vm. Now if this time taken is t1 and if this time taken is t2, so giving t1 plus t2 equal to t. t1 plus t2 equal to t. Now what the acceleration? A equal to, we know, slope of VT graph. So this becomes Vm by t1. This becomes Vm by t1 because this is Vm, this is t1. So slope equal to perpendicular by base. So Vm equal to A t1. Again slope of this line is B. So B equal to perpendicular by base. Here time taken is t2. So Vm equal to B t2. Now this and this become same. This and this equal to B t2. That is t2 equal to A by B t1. Now total time taken is given t, so t1 plus t2 this, so t1 equal to bt by A plus B. So maximum velocity equal to A into t1, which is this. So this is the answer. Now what is the distance travel? We know area under VT graph equal to distance travel. So area equal to half base base equal to t total time t into height equal to Vm. So Vm equal to AB t by a plus b. So this is the answer. So this is the answer. Graphs in kinematics, that is motion in a straight line. So here the formula is, first you have to know the formula, slope of xt graph equal to velocity, slope of vt graph equal to acceleration, slope of vt graph equal to acceleration, distance, area under vt graph equal to distance travel. Here sometimes distance travel and displacement. This first know the formula. And area of AT graph represents change of velocity. So this is the basic formula of graphs in kinematics. Now also we have to know some graphs. Suppose this is x and y equal to mx, this is the straight line passing through the origin, y equal to mx. And suppose this is yx, y square equal to kx. This is the equation, this is the graph of parabola whose equation is given by y square equal to kx. And if graph is this yx, so this is the x square equal to ky. So and y equal to mx plus c, y equal to mx plus c. This is x-axis, y-axis, y equal to mx plus c. Here c is the intercept and m is the slope of this line. Slope of the line, we have to draw the slope of the line. So first we have to draw the straight line. Equation of the straight line is given. Suppose equation is this. How we draw the straight line? The straight line will be in intercept form. If we know the intercept form of straight line, suppose this is x intercept, this is y intercept. So equation of the straight line be this. So if we know the intercept, x intercept and y intercept, we can easily draw the straight line. So we to draw any straight line, we have to express the straight line in this form. So here this, now this is y-axis, x-axis. So 4, 1, 2, 3, 4 here, and minus 4, 1, 2, 3, 4. This is minus 4 and this is 4. So line will be this. This is the graph of the straight line. So first you have to know how to draw the graphs. The basic graphs I have shown. The basic graph already I have illustrated. Now what is the problems related to this graph? Suppose this is x, this is a graph, and at xt graph, at which point, question is here, at which point velocity is 0, and B and C, at which point velocity is more, B or C. So to draw the velocity, we have to know, we have to draw the tangent at each point. So we know slope of this point means slope is only the slope occurs in the straight line. So if we draw the tangent at that point, then this line is parallel to t-axis. So velocity at a equal to 0. because slope of the line parallel to t-axis is 0. What is the slope? Slope means tan of theta. What theta is? Angle of straight line with x-axis. Here x-axis is t-axis, so this line is parallel to this, so this line makes an angle 0 with t-axis, that is slope is 0. So slope 0 means velocity at 0. At which point velocity is more? Suppose this angle is theta b and this angle is theta c. From the graph we know that theta b greater than theta c, so tan, that is acceleration of, that is velocity of b is greater than velocity of c. A graph is given this. What is the type of body? What is the type of motion of body? Acceleration motion, rest or moves with uniform velocity. Acceleration motion or rest or move with retardation or uniform velocity. So how we recognize this? Actually this is the part of the parabola. This is the part of the parabola. The equation is here x is along y-axis and t is along x-axis. So I have illustrated that this type of parabola is y equal to kx square. Y equal to kx square. Y equal to kx square graph is this way. So here t is x and y is x. Y-axis along x-axis. So equation becomes x equal to kt square. So if we dx by dt equal to k into 2t, and this is velocity, and acceleration equal to dv by dt, that is 2k. This is constant. So this is constant acceleration. This is the graph of uniform acceleration. So if xt graph is like this, then this is the equation of, this is the uniform acceleration. The type of motion of the body is uniform acceleration. This is v, this is x, and one graph is this given. So what is the type of motion of graph? Now this is, we know from this x, y, what is the equation? Equation becomes y square equal to kx. Here y is along v, so equation becomes v square equal to kx. Now if we derive with respect to x, so 2v dv by dx equal to k, that is v dv by dx equal to acceleration, so a equal to k by 2, that is constant by 2, that is constant. So here this also uniform acceleration, y square equal to kx. So type of motion of graph will be v square equal to k. Differentiate with respect to x, then this differentiation becomes this. So a equal to, this is a equal to k by 2. Graph cannot possible when, if this is suppose xt, a graph is given this way. So this graph is not possible. So, and this, suppose this is x, this is t, and the graph is giving this. So this is not possible. Why this type of graph is not possible? Because time cannot decrease. Time is always increases, and so here up to this time is increases, but after this time backs, that is time decreases. So this graph is not possible. And here also this is x, this is t. Here, sorry, this is t, this is x or v or x. So here also time decreases, and here at same time there is two position. At same time the particle has two positions, so it cannot possible. So this type of graph is not possible at nature. Conversion of graphs. Suppose this is meter, this is second. So find its velocity time graph and acceleration time graph of this graph. So how we convert this graph to velocity time graph and acceleration time graph? Now this is for first part 0 to 2 second solution. For 0 to 2 second, equation becomes x equal to a square, x equal to y equal to x square. Here y is along x axis, here y axis, here x is along y axis, and t is along x axis. So x equal to kt square is the equation of this path of this graph. So x equal to kt square for 0 to 2 second and 2 to 4 second. What is the equation? Equation is x equal to 8, x equal to 8, and 4 to 6 second. What is the equation? So here equation is equation of straight line. Equation of straight line, we know y minus y1 equal to m into x minus x1 if a straight line passing through a fixed point and slope is given. The equation is this. So here equation is, this point is actually 6, 0, x is 6, y is 0, 6, 0. So the equation becomes y means x minus x1, 6, 0, x minus 6 equal to m. What is the slope? Slope of the line is tan theta equal to perpendicular base 8 by 2 into base x minus x1. So here x1 equal to 6, x1, y is x, into x. Here image slope of the line is 8 perpendicular by base 8. This is 8, this is 2. 4 to 6 means 2 into x axis is t minus 6. So this is the equation, x equal to 40 minus 24. So this is the equation, this and this. Now what is the velocity time graph? So just derive 0 to 2 second dx by dt equal to, now you can find the k also. When x equal to 2, what is when t equal to 2, x equal to 8. So 8 equal to k into 4, k equal to 2. So x equal to 2t square. Equation is x equal to 2t square, dx dt equal to 40. So this is the velocity graph. So we get velocity equal to 40. Now 2 to 4 second. What is the x equal to 8? So here velocity equal to dx by dt, which is equal to 0. If we derivative with respect to t, constant term, so derivative is 0. Now if 4 to 6 second, what is this? Velocity equal to dx by dt. So this becomes 4 minus 0, that is 4. So we get the velocity equation 40, 0, 4. Velocity time graph will be 0 to 2, 4, 6, 0 to 2 second, v equal to 40, y equal to mx. Now 2 second velocity is 8. Now 2 to 4, what is the velocity? Velocity is 0. So 2 to 4 velocity becomes 0 velocity, and 4 to 6 second velocity equal to constant 4. 4 to 6 velocity equal to 4. So this is the vt graph, and if we draw the at graph, so velocity equal to 40, a equal to dv by dt, that is 4. So acceleration up to 2 second 4 constant, and 4 to 6 second velocity becomes 0. So v is equal to 0 means acceleration also 0. And next, this is 2, 4. Next 4 to 6 second acceleration, velocity is constant, so acceleration is 0. So this is the at graph. How? So this way we can convert one graph to another graph. So to convert one graph to another graph, we have to find the equation of the straight line or equation of the graph. We have to find the equation of the graph. This is the theory part of the motion of a straight line. Now main problem series of NEET, especially year question and very important problems will be discussed in another video. The students, if you watch the NEET crash course video of the NEET crash course, then I can assure you that you must crack the NEET exam with confidently with a good rank. Okay, thank you.